Hello, this is module for investigation one. We're going to talk about percentage and the percent change. So the percentage refer to the type of the measurement where the measurement unit is a specific proportion of the quantity. And to be exact, 1% of the quantity, which is a 1/100th of the quantity of the values. So we're going to talk about the number 3 here. Okay. So let's talk about number 3. The idea of the percent or something allow us to making a direct comparison by considering the parts of per hundred, or the number of 1/100th of the one quantity compared to the number of the 1/100th of another quantity. So A, an acid mixture used by one lab technician contains 32.4 milliliter of acid combined with 90 milliliter of water. A second lab technician makes a mixture with a 26.8 milliliter of the acid and 67 milliliter of the water. We want to know which technician made a stronger acid mixture. So number one, how can percentage calculation help us to make the necessary comparison? Because when you just have a number like 32.4 milliliters acid and 90 milliliter with the water, another one has 26.8 with the acid, and then the 67 of the 67 milliliter for the water, right? So at the number you see, I don't know exactly what could be the stronger or the other, but if you are using the percentage, easy to compare because because the percentage calculation, it is useful to consider the number of 100th of the one quantity compared to the number of 100th of the another quantity. So you can easily see which one has a more percentage than the other. So number 2, which technician made a stronger acid mixture? Just find your answer. So the first mixture there has always a percent, always the total of parts on the top and then multiply by 100. Okay, so first mixture has the parts is we're looking for the strength of the acid from the combined with the acid with the water, and then multiply by 100, and then I'm getting the 26.47%. And then second mixture to come out as the higher or the lower, and then we can see which one is the stronger. So second mixture has a 26.8 of the acid and 26.8 with the come with the water, which is 67. And then when you use a calculator, I get 28.57%. Okay, so as you notice, 28.57% is the stronger, the more than the 26.47. So we wouldn't say second mixture is stronger. Okay, all right, let's do B. World Meter Statistics Reporting Service report that the death rate for those testing positive for the 2003 SARS virus was 10% of, while the death rate of those who testing positive for the COVID-19 through the June 9, 2020 was about the 5%. So they're talking about the death rate. And then the 2003 SARS is a 10% is a death rate. and then the COVID-19 is 5%. So in number 1, explain what this data tell us about the 2 virus outbreaks and what is the data does not tell us about the outbreaks. So the data tell us in here is the SARS death rate is a 10% and then COVID-19 is a 5%. So it looks like this data conveys that the SARS virus is 2 times more deadly than COVID-19, right? Because SARS death rate is 10%, and then COVID-19 is 5%. But what this data does not tell us? Well, out of how many, right? Out of how many 10%, out of how many 5%. So this data does not provide. So let me use another color, okay? So this data doesn't provide information on the total numbers of positive case. Because even though it's a 10% death rate for the 2003 SARS, but I don't think that is that much of a notorious than the COVID-19. Yeah, because the COVID-19, I think that everyone who live in the earth knows, right? But 2003 SARS, I don't even know at the time that there was that kind of virus we had. So number 2, 2003 SARS outbreak saw 8,000 people worldwide infected with the virus while through June 9th, 2020, experts calculate that there were 7,238,500 confirmed cases of the COVID-19 worldwide. What else do we know about the 2 outbreaks based on the given information? So, well, from here, even though the death rate for the SARS was greater, which is 10%, and then the COVID-19 is 5%, but if you compare about number, right, 7,238,500 and divide by 8,000 from the number of the SARS positive case, and then the COVID-19 is 905 times as many cases of the COVID-19 than the case of the SARS. So, which means we can also kind of think about this way too. So now you can see how many people has been died, right? Which is 10% of 8,000 for the SARS, which is about 800 people die. For 2003 SARS, but 5% of at the time of the June 9th, right? June 9th, right? Of the 7,238,500, which is about, let me use a calculator, which is about 7,238,500 times 0.05. I have about 361,925 people die from COVID-19. Okay, so we got this. Okay, so as you notice here, right, even the SARS is a 10% and the COVID-19 is a 5% death rate, but as you notice here, the COVID-19 has a lot of people, right? people, right, die from the COVID-19, right? So this is a lot bigger, right? And then see, come up with the two examples of situation where you see the percentage used in the real world. Number one, explain what percentage value represent the context here. So in number one, a percentage represents a measurement value where the measure unit is a proportion of quantity. And number two, what benefit of the using the percentage measurement in the context? So the idea of the percent allow us to make a direct comparison by considering the parts per hundred. So using the percentage actually give us the idea of the percent, allow us to make direct comparison of the two quantities. Okay, so one quantity you figure out as a percentage, other one you figure out another percentage, and then you can compare the percentage each other to see as which one is a more stronger, which one is a more deadly effect on from the virus. Alrighty, I think that's all I want to say from this section. Thank you for listening.